Okay guys, this is the video. I'm just gonna go straight through the Unit 1 review packet. So just follow along. I'm gonna try to show all my work, but you can skip around and just go to the problems that you need. So let's just start from the beginning. This is topic 1A through B and 2D. So this is just a reminder that if you don't know how to do this, go to your notes and find the notes on topic 1A through B and 2D and see if that will help you with these problems. Your notes are a great resource, as are your worksheets. So name 4 arrays that use B as an endpoint. So I'm going to just start by taking my yellow highlighter. Here's B. I want to find arrays that use B as an endpoint. So I can start at B and go towards E. I can start at B and go towards C. I can start at B and go towards D, and I can start at B and go towards A. Remember, the big thing here is for each of these I have to use 2 letters, and the arrow has to go towards the right and start by naming with the endpoint. Okay, number 2, name line L 4 different ways. This line here is line L. So if I'm going to name line L, I need to use 2 points on that line. So we could use E and B. Now my symbol has to have the 2 arrows to show that the line's going on forever. I could do it backwards and do line BE. That's another name for the same line. Let's use E and D now. Those are also 2 points on the line. So I could do ED, line ED, or line DE. It only asks for 4, but I'm going to do 2 more because you could also do BD and line DB. And remember, the line just says I need the line that goes through these 2 points but goes on forever in both directions. Okay, 2 pairs of opposite rays. Remember, a pair of opposite rays, is going to form a straight line together. So notice we could do B going towards E, and we can do B going towards D, and together these 2 rays are going to make up that full line. So we could do B towards D and B towards E. But we could also use this line here and do B towards C and then B towards A. Okay. Name 2 pairs of adjacent angles. In order to be adjacent, you have to be next to each other. So let's see if I can get another color highlighter in here. Here's a pink one. Let's start with this angle right here, angle DBC. In order to be next to angle DBC, you have to share a side and a vertex. So I'm going to share this side and this vertex B to create an angle that's adjacent to the pink one. So take a look. I've got angle CBD and angle ABD. They're going to both share this side and the vertex B. So here's an example. We could have also done DBC again, but instead of going this way, we could have them share this side right here and form this angle. Okay, so the pink angle is adjacent to that yellow angle because they share this side and they share vertex B. So those are examples of adjacent angles. Remember, adjacent means next to. Okay, congruent angles. In order for angles to be congruent, they have to be the same size. And you'll notice in the picture they marked that this angle and this angle are the same size of that arc. And we know that they're congruent because they're vertical angles. So angle ABE and angle DBC are congruent. Okay. Segment EB is congruent to segment BD because they each have 2 tick marks. And the same number of tick marks indicates that they're the same length. And they're segments, so I have to put that segment symbol on top. Okay. Notice for name, we always were using 2 letters unless it was an angle. Okay. And let's move on. True or false? If 2 segments are congruent, They will be, I would say they will be marked. They will have the same number of tick marks. That's true. And we just saw that up above. This says segment AB represents the length of segment AB. Well, remember, if we want to talk about the length, we can't use this symbol. So one way we could fix this, so this statement was false, because this means segment AB, right? This, without the segment symbol on top, represents the length of segment AB. If it helps, instead of using the word, sometimes we use this instead. So if we wanted to call like that, we could, this would also read, the length of AB represents the length of segment AB. Okay. You can use that word. This wasn't wrong. I just wanted to show you, you either have to use the word segment or use the symbol when you're talking about the segment itself. If you're just talking about the length, we don't put the symbol or the word. Okay, 4 points are called collinear. Remember, collinear means together. That co means together. Linear means line. So 4 points together on a line. So 4 points are collinear if they are all on the same line. Yep, that's true. Go on. Okay, suppose the coordinate of P is -4 and the length of segment PQ. Remember, this thing here means the length of segment PQ. What are the possible coordinates of Q? So we know the coordinate of P is at -4, and we know the distance from P to Q is 13. The problem is we don't know which direction to go. We could go this direction 13, or we could go this direction 13. So this could be a possibility for Q. This could be a possibility for Q. To go this way, we're going to start at -4 and go right 13. So we're going to add 13. That's going to get us to a new coordinate of 9. Or we're going to start at P, -4, and go backwards 13. So subtract 13. That gets us to -17. So our possible answers are these. Okay, number 11. Point P is between H and G. So here's H and G. We know that P is somewhere in between. HP has a length of 3. PG has a length of 5. We want to find the length of HG. Well, this is an example where we can do part plus part equals the whole thing. Well, the first part was 3. The second part was 5. Well, 3 plus 5 is 8, so the answer was 8. Or I should really say the length of HG is 8. Okay, I'm going to move on to the next page. Okay, R is between S and T. So if this is S and this is T, R is somewhere in between. RS has a length of 5x, RT has a length of 4x plus 1, and ST, the whole thing, is 28. Well, this is the same thing as before. It's part plus part equals whole. So part plus part is going to equal the whole thing. The part was 5x, the second part was 4x plus 1, the whole thing is 28. So let's simplify this together. This is going to give me 9x plus 1 equals 28. I have to subtract 1 from this side to get just the 9x. So I have to subtract 1 on this side. And when I do that, I get 27. I have to divide both of these sides by 9. And when I do, I get x equals 3. But I want the length of RS. So here's RS, or segment SR, either one. We need to plug in 3. So 5 times 3 gives me a length of 15. If I plug in 3 here, I get 4 times 3 is 12. 12 plus 1 is 13. So the length of RS was 15, and the length of RT was 13. And remember, the length of the whole thing was 15 plus 13, which was 28, which is what they told us. Okay, if X is the midpoint of segment ZY, so here's Z, here's Y, and X is the midpoint. Remember, if we have this keyword midpoint, that tells me that this piece is the same as this piece. And remember, I can use 1 tick mark, I could use 2, but they need the same number of tick marks to be congruent. XZ was 3x plus 4 the length. The length of XY is 2x plus 10. So to figure out what x is, we need to set these equal because of the midpoint. We know that this is the same as this. We have a blank equals blank because of that word midpoint. We know that this segment is congruent. It's the same length as this segment. So I'm going to subtract 2x on this side. Remember, we have an equal sign here. So whatever I do to one side, I have to do to the other side. So when I subtract this, I have an x plus 4 left equals 10. I need x by itself, so I'm going to subtract 4 on both sides. And that's going to give me x equals 6. Okay? What is zy though? We wanted the whole thing. So I have a length of, or an x value of 6. I'm going to plug it in. So 3 times 6 is 18. 18 plus 4 is 22. 2 times 6 is 12, plus 10 is also 22, and that makes sense. This is the middle, so these should be the same length. That means the whole thing has a length of 22 plus 22, which is 44. Okay, so that's topic 1. I'm going to stop the video, and then I'm going to start a new video for topic 2.